done lines and line segments. Now let's get into some angles. All right. First, we got to talk about what an angle is made up of. For example, our first definition here, we have a ray. It's part of a line that extends indefinitely in one direction. Okay, so just one direction. So if I have a point and another point, A and B, okay, it only extends indefinitely in one direction. So it still goes through 2 points, but one of them is an endpoint, and it goes to the other one indefinitely. Okay, so it doesn't go through both. And we state this, we can label this as A, B, with an arrow on one end. And you have to be specific, right? If you look here, the arrow is extending through B, so that means when I label it, I have to have the arrow extending through B over here as well. Okay, so I could not label this like this. That won't work. I also can't label it like this because the arrow is not extending through A, it's extending through B. So it has to be this way. Okay, opposite rays, 2 rays to the common endpoint. So pretty much if I have a point here, okay, and I got a ray going this way through B and a ray going this way. Oh, that's not very opposite, was it? If I had a ray going this way through C, okay, AC would be opposite to AB, right? The 2 rays. Those would be opposite rays. So they basically make a line, wouldn't they? Okay, talking about how rays form our angle now, all right? So an angle is formed by 2 non-collinear rays that have a common endpoint. A common endpoint. So if you look here, we have a common endpoint between these 2 rays and Y. That's our common endpoint, right? And we call that endpoint the vertex. That's what we call the vertex, all right? So where our angle meets at, basically, is called the vertex, that point. And we can name this angle various ways, right? The most common way to name an angle, especially when it's given a number inside of here, is we can just name that angle 1. So I would say angle 1. If I wanted to state the measure of angle 1, let's just say it's 30 degrees. I have no idea how much it is. I would have to say the measure of angle 1 equals 30 degrees. Okay, so I have to put that little m in front if I'm going to state the measure. Okay, well, what if it didn't give me a number there? Okay, well, it didn't give me a number to state that angle. Well, then I have to use 3 points to state my angle. I still use this angle symbol, and I got to use 3 points. Well, I should know which point should go in the middle on X, Y, and Z. If I think about it, I'm looking from X to Y to Z, right? That angle right in there. So I have to say angle X, Y, Z. The Y has to go in the middle. I could have went the other way. I could have started at X and said Z, or started at Z and went Z to Y to X. That's fine. I could have said angle Z, Y, X. Either way. Also in this case, I could have stated just angle Y. That's fine. You don't always want to do that, just in case something like this happens. What if my drawing would have had another ray going like this? And let's just name that A. Now I couldn't say angle Y, could I? That would not apply. Because I don't know if we're talking about this, or if we're talking about this angle, if we're talking about that entire angle. So I couldn't just say angle Y there, right? If I wanted to state this angle, I'd have to say angle AYX, or angle XYA, right? So you got to be specific when you name angles. Well, an angle divides a plane into 3 distinct parts, right? We have points on the angle, which you can see right here and right here. We have points interior to the angle, or inside, here and here, and points exterior, or to the outside. Well, there's a point to the outside of the angle, outside of the angle, right? Pretty basic, pretty basic. All right, let's do some naming here. So name all angles that have B as a vertex. Well, if I look up here, here's my vertex B. It looks like 5, 6, 7. All those angles have a vertex of B, and same with this angle right here. It's not labeled, right? That B is labeling this point. It's not labeling the angle. So to be very basic, for 5, angle 6, and angle 7, I could just say angle 5, angle 6, angle 7. But for this one up here, I can't say angle B because that's talking about this point here, and I wouldn't know what angle you're talking about. I have to state it as angle GBA, right? B has to be in the middle. Or I could have said, right, angle ABG as well. Either way. Remember, you got to use 3 points. For B, it says, name the sides of angle 5. Name the sides of angle 5. Well, remember, sides of an angle are rays. So you're going to name 2 rays here. Well, here's angle 5. So I got this ray, which is, well, it starts at B and it goes to G. So B, G, and the ray's going through G, right? Sometimes you'll see it written like this, B, G, and it might just have like a little top to the arrow instead of a bottom part with it. Okay, either way is fine. Either way is fine. So BG is one of them. And the other ray that makes up that angle starts at B and it goes through, well, E and F, right? You can name either one, right? Because I'm looking at angle 5. So I could either say BE or BF, right? It doesn't matter. Just pick one or the other. I could have said BF as well, but just pick one or the other, not both, one or the other. And in this case, I'm just going to pick BE. I'll say BE, okay? Either one works. And C, write another name for angle 6. Let me get rid of all my markings up here. So angle 6 is right here. So instead of using angle 6, I have to name it with 3 vertices. So I'm going to say angle, well, I'm going to go with D, B, I'm going to go F with this one. It doesn't matter, E or F. So angle D, B, F. Okay, you got to be very specific when you name those. Classifying angles, this is stuff you should already know. Just remember that an acute angle is less than 90 degrees. Okay, less than 90 degrees. Then you have a right angle, which is exactly 90 degrees. And you'll see it marked with this little box here in the corner to show that it's a right angle. And lastly, an obtuse angle is greater than 90 degrees. Any angle greater than 90 degrees. Well, and to be technically correct, I should say that it's also less than 180. So it's in between 90 and 180. So say X degrees and 180. Just call that X, right? Because 180 would be a straight line, and it wouldn't be obtuse anymore. So this is obtuse. Should have wrote this here too. Right angle, right? Okay. So stuff we know already. So let's classify here. Classify each angle using right, acute, or obtuse. Then measure the angle of the nearest degree. Okay, we're not actually going to measure the angle of the nearest degree. We're going to take our best estimate, kind of based on like using 45 degrees and 90 degrees. Just some easier things to use. So I'm looking at angle TYV. So TYV. So we're looking at this whole thing right here. Well, if I notice, this TX is a straight line, right? And that's 180 degrees, isn't it? And if I notice this right here is 90 degrees, so what's left? Well, this angle right here that I'm looking for, which also has to be 90 degrees, doesn't it? Okay, so I could have solved that one without even using a protractor there. Let's go to the next one. Angle WYT. So WYT. So I'm looking at this whole thing. All right, well, I already know that this is 90 right here, this part of it, right? I figured that out, that's 90. So 90 plus whatever this part is right here. Well, that's about half of this 90 degree angle, right? So it's about 45 degrees, I'll say. So 135. That's why we're just taking our best estimate here. 90 plus 45. Okay? We're not using a protractor at this time. And lastly, TYU. T, looking at Y, looking at U. Well, same thing. I know that this is 90 degrees right here, so it's about, half of that. So this should be about 45 as well. So we'll say 45 degrees. Oh, what did I do? I forgot to classify each angle, right? So up top here, this should have been a right angle because it was 90 degrees. Next one should have been obtuse. And the last one, acute. Okay, this is stuff that you've done before. All right. Angle bisector. Here's a new term, bisector, right? Well, the prefix bi means two, right? Like bicycle, things like that. And bisecting something means cut it in half. Like we're going to cut this bad boy in half. Bisecting. So a ray that divides an angle into two congruent angles. So for example, if I bisected this angle, it would be somewhere around there. So I drew an array, it bisects it. I didn't do a very good job at the front here. So something like that. So what it means is this angle is the same as that angle. They are congruent, right? They are congruent. It bisects it. So if this is 30 degrees, this is also 30 degrees. Just like that. So let's use that information here. It says in the figure, KJ and KM are opposite rays. So they make a straight line. And KN bisects JKL. Usually what I like to do is I like to draw that in right away. So KN, which is right here, bisects JKL. So that means it bisects this big guy right here. So I know that this one and this one are congruent. Those two angles are congruent. I know that. So if measure JKL is 9y plus 15, so where's JKL? JKL, that's this whole thing right here, right? That's 9y plus 15. And maybe I'll write that so we can see it a little better. That's 9y plus 15, that big guy. And JKN, well, that's just this one right here is 5y plus 2. It says find JKL, which is this one right here, that first one we're looking at. So I'm trying to find that, aren't I? Well, if I think about it, what else has to be 5y plus 2? This other one, right? Because KN was a bisector. It was an angle bisector. So now I can set up my equation. Because these two add up to that, don't they? So I can say, well, I can say 2 times 5y plus 2, but I'm just going to add them together. So 5y plus 2 plus 5y plus 2, right? Those two angles add up to my big angle, 9y plus 15. And I was just going through your algebra. So combine my y's over here for 10y, right? 5y and 5y. 2 plus 2 gives me 4, and that equals 9y plus 15. Get your variable to one side. I want to keep my y positive, so I'm going to subtract 9y from both sides. So this becomes 1y, or I'll just write y, plus 4 equals 15. And to solve for y, we subtract by 4. Whatever I do to one side or to the other, that's gone. Y equals 11. Right? That's not my answer, though, because we have to go back and plug it in because we're looking for what JKL is. So 9, so measure of JKL is going to equal 9y, well, y was 11, right, plus 15. And 9 times 11 is 99, and 99 plus 15 gives me 114 degrees. Don't forget that label. So measure of angle JKL equals 114 degrees. So it's just using the information you're given to set up an algebraic equation to solve. All right, there you go. Start working with your angles.